So for number 15, we have to give the converse and contrapositive of each sentence of exercises 10. So we're doing A, B, C, and D. So I've put exercise 10 here side by side. And I've also put in the form of the conditional. So if P, then Q. The converse, if Q, then P, where we switch the antecedent and the consequent. And the contrapositive, if not Q, then not P, where we switch the antecedent and the consequent, and then we deny both. We're also going to have a whenever form. So I've just put here the equivalencies that P implies Q is equivalent to the statement Q whenever P, right? And therefore the converse is P whenever Q, and the contrapositive is not Q whenever not P. And in case this confuses you, just think of the idea of a subset, right? Where we have Q, and then here we have P. So whenever we have P, right, we are definitely in Q. So we can say that we have Q whenever we are in P. Whereas the opposite can't be said, right? Because I can't say that P whenever Q, because I could be in Q, but I could be like over here, and that has nothing to do with P. So let's get started. For A, we're first doing the converse, right? So all we have to do here is identify P and Q. So our P, and I'll put it, our P is F has a relative minimum at X naught, and F is differentiable. And our Q is F prime of X naught is equal to 0, because we have the form if P, then Q. And actually, this should include this. So for the converse, we're just doing if Q, then P, right? So we're doing, for the converse, if F prime of X naught is equal to 0, then F has a relative min at X naught, and F is differentiable. And I'll erase this differentiable at X naught, right? And we have to see if this is true or false. So we're saying if the derivative at X naught is 0, then F has a relative minimum and F is differentiable, right? But that is not true, because I could have my function y is equal x to the power of 5. So when I take the derivative, y prime is equal to 5x to the power of 4. And then when we evaluate it at 0, this is clearly going to give me 0, right? But I don't have a minimum at x equals 0. So because it doesn't turn around, right? It's increasing all throughout its domain. So this one is false. Now let's do the contrapositive. Contrapositive. So what we're doing is, the converse is if Q, then P. So for the contrapositive, we're just denying Q and we're denying P. So we're saying if F prime of X naught does not equal 0, then F does not have relative minimum at X naught. Or remember that when we're denying, say, P and Q, it goes not P or not Q by De Morgan's laws. Or F is not differentiable. Let me zoom that out. At X naught. And let's see, is this true or is this false? Well, if the derivative is not equal to 0, right, then clearly we won't have a relative minimum or maximum. Or if that's not the case, we can't differentiate it, right? So it's one or the other. If we can differentiate it, it does not have a minimum, or we can't differentiate it, and that's why it's not equal to 0. So this one is true. All right, let's do B. So B, we do have to identify our P and our Q. So our P is if n is prime, then, oops, no. Our P is if n is prime, right? This is our P. And our Q, then n equals 2 or n is odd. So we're going to first do the converse, where we're switching things up. So for the converse, we're just going to switch it up, right? So we're going to do if n equals 2 or n is odd, then n is prime. Now let's see, is this true or false? Well, take n equals 9, right? If n is equal to 9, then the statement if n equals 2 or n is odd is true, right? Because for a disjunction to be true, just one of them have to be true, and 9 is odd. However, 9 is not prime. So the statement here is false. Now let's do the contrapositive, where we're going to deny Q and deny P. Contrapositive. So we're going to, if n does not equal 2, and remember that when we're denying a disjunction, it becomes a conjunction by De Morgan's laws, and n is not odd, right? And n is even, then n is not prime. Now this one is true, right? Because if the only way for an even number to be prime is 2. That's the only even number that's prime. So if it's not equal to 2 and it's even, then it's not prime, right? Because it's a multiple of 2. So this one is true. And maybe I'll just highlight these so that we can kind of access it easier. False, true, right? Let's do C. Now C, we have the whenever language, right? So we have here in terms of Q, whenever P. So our Q in yellow is this one, and our P is X is irrational. So we're not going to first express it in terms of if, then. We're just going to use the whenever language, right? But then just switch things around because that's the easiest way to do it. So C, we're going to just switch it around. We're going to say X is irrational. Oops, I should have said converse. X is irrational whenever X is real and not rational. Real and not rational, right? So X is irrational whenever X is real and whenever X is rational. This is true. So this one is true, right? Let's do the contrapositive. Contrapositive. So for the contrapositive, we are saying we're just keeping the same form, but then denying Q and denying P, right? So we're saying X is not irrational, right? Not irrational whenever X is not real, right? X is not real, and once more through De Morgan's, or X is not rational, or X is rational, right? Rational. Now for this one, what we're saying here is X is not irrational. So another way of saying it is X is rational whenever X is not real or X is rational. And this is true, right? Because the only way that it would be false is if the antecedent is true and the consequent is false. However, if the antecedent is true, if X is not irrational, therefore x is rational, then x is rational, right? So our consequent is automatically true. So this one, we can also say that this one is true. All right, and we're just missing one more. We're just missing our item D. So P is if x equals 1 or x equals -1, and Q is absolute value of x is equal to 1. So for D, we're first doing the converse, and we're flipping these around. So we're saying if the absolute value of x is equal to 1, then x is equal to 1 or x is equal to -1. And this is true, because that's the definition of the absolute value. And contrapositive, so we're just denying Q and P. So we're saying if the absolute value of x does not equal to 1, then x does not equal to 1, and through De Morgan's, x does not equal to -1. And this is also true by the definition of the absolute value. So let's just highlight this. And yeah, we are done here. So let me just zoom out so you guys can see everything. And that is it.